I'd like to take a moment to talk about undefined expressions. So an example of an undefined expression is where 0 is the denominator in a fraction. So if we had 8 over 0, do you see that 0 is in the denominator? If 0 is in the denominator, that means that this expression is undefined. Undefined. If there is ever 0 in the denominator, we are not able to ascertain the actual quantity of what the expression is trying to denote. We just don't know. So whenever there's 0 in the denominator, the only conclusion that we can make is that this expression is undefined. We can't say that it equals a number. We can only say that it is undefined. And so that is true no matter what the numerator is. If the numerator was 8 or 800 or even 0, it's still going to wind up as being an undefined expression. And so there are a couple reasons or ways that we can explain why that would be undefined. And one explanation might sit better with you than another. So I'm going to do 2 explanations and maybe one will catch on for you. One reason why we could say that 0 being in the denominator does not make sense. So because it does not make sense in mathematics, when something doesn't make sense, we tend to call it undefined. So, or if something is nonsensical, we tend to call it undefined. Instead of saying that's a nonsensical answer, we sometimes say that's an undefined answer instead. It means nonsensical. So if we have, let's say, a pie, like a pizza pie, and we divided it into fourths, equal fourths, what I would be able to say is, I have 4 slices in total. That's what the denominator shows. This is the total slices. That's what the function of a denominator is in a fraction. The function of the numerator is how many slices are chosen. So how many chosen. So if I were to choose 1 slice, then I would have chosen 1 slice out of the 4 slices, and then I would say the shaded region represents 1/4 of the entire whole. So it would be 1 over 4. If I said 2 over 4, then I would be shading in 2, so that would be equivalent to half the pizza. And it's no coincidence that 2/4 can be reduced to 1/2, because we have 2 halves of the pizza. Do you see that if I had only made 2 slices, meaning 2 halves of the pizza, and I shaded this entire top half in, that would be 1 shaded part out of 2 parts. So 2 out of 4 parts is the same thing as 1 out of 2 parts. So that's what a fraction normally does, but that breaks down, that analysis breaks down when we don't have a pie at all. So let's say that I choose 2 slices out of no pizza pies. Well, if I don't have a pizza pie in the first place, I certainly can't choose 2 of those slices. So this is nonsensical, or we say undefined. So if that explanation is good for you, you can probably stop the video and go on. If that explanation didn't sit well with you, or you want to know a little bit more, there's a slightly more accurate way that we tend to discuss what undefined expressions are, and you'll get to this later on in high school, but may as well start it now. When we get to infinities, infinities sometimes mean nonsensical answers also. When you get to extremely large numbers that go on forever, it's impossible to comprehend, and we don't really understand what's happening at the end of infinity. So we call it undefined. So let me show you how a fraction with 0 in the denominator can represent infinity. By the way, if you take calculus later on, you'll see that these infinities really represent asymptotes, which is a limit. So you don't need to know that, you just need to know the understanding behind what those words mean. So let's say that we had, let's start off with just a regular old fraction. Let's say that we had 5 over 5. 5 over 5 is, think of a pizza that's split into 5 sections. 1, 2, 3, 4, 5. Let's say they're even sections, okay? And let's say you chose 5 slices of that 5 sliced pizza, okay? You eat the entire pizza, you eat the whole. So that's why this is otherwise known as 1, okay? So any number over itself, except 0, any non-zero number over itself will always equal 1. So 8 over 8 will equal 1. 800 over 800 will equal 1, because you're just taking 800 slices from a pizza that has been divided into 800 slices. So I could divide this into 800 slices, okay? And it would still be the exact same pie. I'm not eating more pizza, even though it's divided into 800 slices. The reason why I'm not eating more pizza is because each slice is that much tinier. So I'm eating 800 slices, but 800 really tiny slices. So it still comes out to 1 whole, all right? What happens when I reduce the denominator? If I reduce the denominator, the overall fraction increases. Look at this. If I go down to 5/4, if I make the denominator down to 4, 5/4 is actually greater than 1. Do you see that? So if the denominator decreases, the overall fraction increases, because 4 goes into 5 1¼ times. So this fraction right here is being represented by, I have 1 slice of pizza, pizza that's divided into 4s. I have 4 slices, divided into 4 slices, plus I have not just 4 slices, but I have 5 slices. I have 5 of these quarters. So that means I have 1, 2, 3, 4, and then a part of another, a quarter of another pizza pie too. So if I want 5 slices of quarter slices, I'm going to be eating an entire pizza plus the quarter of another pizza. So that's, do you see how if this denominator goes down, then the overall fraction is representing something that's greater than 1, okay? In fact, if you were to turn this improper fraction into a mixed number, you would do 4 into 5, and 4 goes into 5 1 1/4 times. All right? Let's take this to its logical conclusion. If 4 gets reduced to 3, then this overall fraction becomes bigger, even bigger than before. And if this 3 as a denominator turns into a 2, then this turns into an even larger fraction. In fact, this turns into 2 goes into 5 times 2½ times. Do you see how it went up from 1¼ to now 2½? If I reduce the denominator to 1, it becomes even bigger. It now becomes 5. It goes from 1¼ to 2½ to 5. Do you see how this overall fraction is increasing? Actually, it's increasing at an increasing rate. It's actually getting much bigger, much faster. So if I then say, okay, let's make this 0.5, or maybe 0.1. Do you see how the denominator is getting really, really, really small, making this fraction really, really, really big? If I have 5 over 0.1, that would be equivalent to putting 0.1 into 5. okay? Which, in order to divide, I need to go move this one, move this one. 1 goes into 50 50 times. So 5 over 0.1 is 50. Okay? So do you see how when the denominator gets smaller, the entire fraction is equivalent to a much larger number? So if I were to reduce the denominator to like 0.00000001, this would go into 5 many, many, many multiples of 10, all right? In fact, the smaller this gets, the larger this number gets, so that if I go all the way down to 0, this overall fraction becomes the biggest number we can possibly think of, which is infinity. And if we come up with infinity for an answer, oftentimes in mathematics, we call that undefined, because we really don't understand what's going on because we can't grapple with infinity. So that's a longer reason of why you cannot divide by 0. And that's why if there's ever 0 in the denominator, since we cannot divide by 0 for this nonsensical answer, we call it undefined. So hopefully that helps out a little bit. And if not, you can talk to me in class.